So today we're going to go over, just briefly go over Newton's first law, and then, but more focus on net force, which is part of the first law. Okay, so the first law, you've probably seen it in action. It's pretty simple. It basically says that an object that is at rest or in uniform motion. What I mean by uniform means that it basically just has constant velocity or something with a constant speed, or the uniform motion. Okay, so it's stating that anything that is at rest or uniform motion will not change unless it has a net force. Okay, so unless it has a net force, okay, which is what we're going to go over today. And kind of another way to say that, another way to say a net force is it has an unbalanced force on it. Okay, so something has, we've seen already, right, that when something has an unbalanced force, we have motion. Okay, so that's the definition, and we're going to work through some couple of examples. Okay, first, let's define. We've already defined this, but let's define it again. What is force? What is force in our physics class? We're going to define force as a push or a pull. So it's kept very, very simple. Anything that can push something or pull something, that is a force. Okay. The units for force are going to be newtons. Okay, so that's how we measure force, newtons, often represented with a capital N. Okay, so there's force and there's also net force. Net force is slightly different. It's the same thing, but when we're talking about a force, that's just a single force. When we're talking about net force, that's the sum of forces. What do I mean by sum? I mean the addition. You add up all the forces, and whatever you get, that is your net force. Okay? All right, so again, forces, our units are newtons, and again, we'll go over different type of forces in the future, but again, net force, a force is just a push or pull, such as gravity, such as an applied force, friction. There's a bunch of different forces which we'll go over. But the first law, it's a pretty obvious law, which we always see, right? So if I have this marker here and I leave it, it's going to remain at rest if there's no net force. But if I put a net force on it, then its motion is going to change. Okay. Same thing. Let's say it's traveling through space, though. If this is traveling through space at a constant speed and there's no forces on it, then that's just going to continue traveling at that constant speed forever. Okay. Unless acted upon some type of external force. And we'll go over it in some more detail later, but I kind of just wanted to bring up the concept of net force because that's what we're going to be going over today. Okay, so force, kind of going back to force. Force is what we call a vector quantity. Okay, that just means it has magnitude and direction. So if you think back to our motion unit, there was something that was similar to that, which was velocity. Velocity is also a vector. Okay, so for example, vectors are usually represented with arrows. So let's say I have a force that looks like this. All right, it's 5 newtons. Okay, and I would say to the right. So 5 newtons is my magnitude, how big the force is, and right, well, that's obviously my direction. But when we're using arrows, the size of the arrow matters, because in vectors, a larger arrow represents a larger force. So this would be something like 10 newtons, right? Okay? And you'll also see arrows to the left, right? Because the force can go right, it can go left, it can go up, it can go down as well. So this would be something like this would be, let's say this is 4n to the left, right? Or you might see something slightly bigger, 6 newtons to the left. So again, the point I'm trying to get across is that the length of the arrow matters. Larger arrows equal larger forces. Okay, you're often also going to see when it's going left, you might also see a negative sign on it. Okay, and we'll go over why that is and how that affects net force. But kind of the reasoning behind that is, if we have a number line, and let's say this is 0, every time we go left, the numbers become less, so they become negative, right? And whenever we go to the right, those numbers become positive, or they become larger. Okay, so that's why this is positive and these are negative. Left is always negative, positive. Same thing as a number line. All right, let's go through some examples, and this is what you actually have. This is what you have to do, is calculate net force. So that was just kind of the background information, but let's go over the scale. What do we actually have to be able to do? Which is calculate net force. Okay. All right. So say I have a box. In physics, we often represent objects as simple squares. We could keep it more. We could make it more complicated, but there's no reason to. Okay. So let's say I have two forces on this. I have a force of 5 newtons and a force of 10 newtons, making sure this 10 is slightly bigger, right? So if I'm trying to find the net force, my net force, which I'm just abbreviating, equals the sum of these. So I add them up. So 5n plus 10n. So 5 newtons plus 10 newtons would give me 15 newtons. Because this is positive, it's going to be to the right. Okay, so this object would move to the right because it has a net force of 15 newtons to the right. All right, pretty simple. Let's start getting a little bit more complicated, but it's still going to be relatively simple. Let's say I have another object, a force of 7 newtons to the right, and another force of -3 to the left. So they might not put negatives, but you know that if it's going to the left, we're going to consider it to be a negative number. So if we're trying to find the net force, we're going to say it's 7 plus, well, this is going to the left, so it's going to be negative, -3n. Okay? So 7 plus -3 gives us gives us 4 newtons. This is a positive number, so it's to the right. Which makes sense because this is the force to the right is greater, right? So that would win, and our force over our net force, which is our overall sum, should be to the right. Okay. What if we have multiple forces? Like, what if I have an object in which I have a force of 5 newtons to the right, then I have a force of 10 newtons to the left, and slightly smaller 8 newtons. Okay? Well, I'm still doing sum of forces. I'm still adding up all of my forces. So 10 and 8, so let's say I'm finding the net force. I'm just going to, those are negative, right? So 10 newtons plus 8, -8 newtons. I made these negative because they were going to the left, plus 5. Okay? Let's see here. So -10 plus -18 would give me, plus -8 would give me -18. Plus 5. I add those up. That gives me -13. Right, so if I'm on a number line, I go to -18, then I go 5 to the right, which will give me -13. And, okay, because this is negative, I got to put left. And then we can double check. Does it make sense that it was to the left? It does, right? Because there's greater force to the left. So that's why it makes sense that it was negative and it was to the left. Okay? And whenever you're doing your work, make sure you guys circle your answers or square your answers just so I can identify it more easily. Okay, let's go through one more example. Let's just say I have something that looks like this. I have a force of 5 newtons and a force of 15 newtons. Okay, 15 plus 5, well, they're both negative. 15n plus 5n negative, right? Because it's to the left, would give me -20n. So you can't just go 5 plus 15 because then you wouldn't get a negative number. Don't forget direction, left. That would be the final answer. Okay? Keep in mind, there's a few problems that you might also see this, so I'm going to bring it up. You might also see a force going up and down. So you might have a force like this, like a force of 10 newtons and a force of, let's say, 5 newtons. So in this example, what do we make negative and what do we make positive? Okay. Well, if we look at a number line, like an X and Y number line, in an X and Y number line, positives, when we go up, we become positive, right? But when we go down, we become negative. So same thing here. When it goes down, it's negative. And when it goes up, it's positive. So this would be positive 10 because it's going up. Positive 10 newtons plus, actually let me erase that. That could be kind of confusing. Positive 10 plus negative 5 newtons. Would give me, would give me 10 N. And it's positive, so that means up. Okay. So you might have a few examples. For the most part, most would be like this. But I want you to know it's basically the same thing. But going up would be positive, going down would be negative. Okay. And whatever the direction the net force is in, is a direction that object is going to move in.